So, are we all ready for our lightning talks? Excellent. Fantastic. So our first talk is going to be Connor Shorten from Weaviate, and he's going to be talking about filtered vector search. Connor.
Awesome. So everyone, thank you so much for giving me the chance to talk. I'm going to talk about a topic that I think is super cool, which is filtered vector search. So not just looking for the nearest neighbor, but also having categorical filters as you traverse the nearest neighbor index. So quickly not to force the Weaviate on you too much, but with Weaviate, what we do is at the top you see how you have the near text, which is where you take text and you turn it into vector to send into the vector search. And then underneath that you have the categorical filter where, so in this case I'm searching through the Weaviate podcast clips and I say, I want to know about how do large language models use databases, but then I also want to filter the results based on from this particular podcast with Harrison Chase and Bob Van Light. So to give a quick background on HNSW, maybe is a quick lightning talk. I also realized I forgot to start the timer, so I don't know how. Oh, all right. So how many people in here already know how HNSW works? Okay, super cool. So then I'll probably just go over quickly. So I've modified the picture a little bit from the paper to have like the query point at all the layers. So you start off on the top layer, you see which is the nearest neighbor. So the green point is our, I don't know if there's a mouse or, but yeah, so the green point's our query. You see what's nearest to that. And then you go down and, so basically the proximity graph, it has the edges to the neighbors that you use to do the distance comparisons. And this heuristic lets you, only compare so many distances. So you're not, doing the distance between your query and then all the vectors in your collection. So you go layer by layer. And so what we're modifying with the filtered edition is now when you're traversing through the graph, in order for it to be added to the candidate set for what's returned from the search, it has to match the filter. So one other thing is, if you want to learn more about this, we have documentation on it, which is this roaring bitmaps, which is just making it really fast to get the category matches and then integrate this with the graph, which is, again, as you're traversing it, doesn't match the filter. And then maybe one other interesting thing is about the specificity of the filter. So the specificity of the filter is about, what percentage of your data set matches the filter. And if it's super specific, you might be best off just brute forcing it. So it's another kind of interesting aspect of this. So I think with the large language models, they add some really interesting things to filtered vector search. And I think the first of which is the ability to extract structured data with large language models. I think one of the coolest things about vector search has been, you just point it to a website, some PDFs and something like that, and you just chunk it, and then you can just search through it. And you don't have to kind of manually annotate it. But now these large language models are really good at also kind of extracting the structured data, adding this to your chunks, so you have this additional kind of chunking with it. So, if you want to say which NBA players, went to the University of Texas for Kevin Durant, these kind of filters adding to it. So, I've been talking to a ton of interesting companies, projects in this space that are working on extracting structured data with large language models, and I think it's super interesting. And then the next thing is about traversing structured data with large language models. So, imagine prompting the large language model like this. The query is, how do I use ref2vec for my e-commerce recommendation system? And so now you prompt it to add where filters to its vector search by saying, you have access to a search engine to retrieve relevant information for this question. You have access to the data sources, the Weaviate podcast transcriptions or Weaviate code examples. Which would you like to search through? And then please format your answer to be just the data source you want to search through. And then the large language model tells you Weaviate code examples. So you can prompt it this way to put where filters onto it. And this way you can kind of use the language model to do this kind of like query parsing and navigating your data. And here's another example that's really interesting where it's about the composable indexes in Llama Index, where there's the New York City Wikipedia page, and then there's also the Paul Graham essays. So you ask a question like, where did Paul Graham grow up? And it will route the query to the appropriate index. Cool. So I think something else that just makes this extremely interesting is this kind of role-based access control kind of question where, you can have you could have a class for every user, or you could have one class with filters where the filter is, the access. So like, if it's an organization, who can see which documents and that kind of thing. And, how you want to distribute this is another part that makes it really interesting. Because another thing about this that makes it so interesting is the filters. It's not just like about they have some kind of semantic match, like they share the same color. The filters could be just like totally unrelated to the semantics of the vector embedding, and that's another kind of interesting thing to this. So quickly, I was going to see if I had time to. Okay, so just if you're curious about some ways to improve filtered vector search, there's this really cool paper called Filtered Disk Annon. And basically, they propose a couple ways of modifying the pruning heuristic with either, a new way of kind of over-sampling the candidates and then pruning based on filter overlap, or like separating the data based on filters and then merging the HNSWs later on. So great. So I hope this is a cool talk about why filtered vector search is exciting, and thanks so much for listening.
Thank you, Connor. Right, so our next talk is from David Tippett. David.
That's the talk. That's it. Also, I just found out like 3 seconds ago that we can do slides. So here are my slides that I put together literally in the last 5 minutes. So today I'm going to be doing a little bit of a pitch more than a talk, and that is search relevancy for observability. So we're all very deep into the search and search relevancy space. However, there's a whole other side of the engineering coin that we aren't really addressing, and that is our observability folks. This is a massive field with tons and tons of volume and logs, and they're supposed to be finding their way through these logs. For those who don't know, my name is David. I'm a developer advocate working on open source OpenSearch at AWS. It's a mouthful. I'm not going to say that too many more times, but if you want to connect with me, scan the QR code. So recently I did a talk for DataOps Poland, and I presented them with this. These are, data engineers. These are people who wouldn't necessarily expect to understand or want to get involved with search relevancy. However, they were very receptive to this. I use this, of course. Most of you recognize it. This is BM25 at its core. This is what OpenSearch uses. And I went through and I talked about the differences between precision, recall, and how these two things are kind of at odds. And, oh wow, the transitions in there too. And I showed them the search comparison tool and talked about, hey, look, you can take the search comparison tool and you can actually have like natural language searches into your log stores. And they were blown away. They're like, you mean we've been typing this all this time and we could just be using natural language searches? And it takes a little bit of work, but my call to action for you all and for the community is we need tools and systems in order for our observability folks to be able to adopt search relevancy. We need to start looking at, hey, can we improve their search experience? Say, for example, I have a log that's 30 characters long, and I have a log that is 500 characters long. Is that 500 character log actually going to give me more information or get me closer to what I'm looking for? How can we better serve people in the observability space that are trying to search through terabytes of logs to find that needle in a haystack? That needle in a haystack. What tools can we build to help them search, find those logs that are the most relevant to them, and not accidentally include every other log that includes the word error? Because if your servers look like my servers, there's a fair number of errors. So how can we be smarter, and how can we help them dig deeper into their data? And one key example here is this is an IPv6 address for those who aren't familiar. And there are a lot of networks that have to use IPv6 and a lot of corporate security policies that won't let you directly copy from your shell. So if I'm typing this out manually, why can't OpenSearch, or any search engine for that matter, help me autocomplete this? we need more support for these types of fields as first-class citizens into our search systems. So with that, please talk to your friends in observability. Help them with relevance. Let's start building some tools that can help the observability folks find the logs that they need so they don't have to type ridiculously terse queries like this that are very fragile with, say for example, I type response 503 because I forgot, response 403 instead of 404. I'm going to get a very different set of results. So maybe we could have, our search system say, hey, you did 403, but that's not a very common error code. Did you mean 404 instead? These are the things we can build for our friends in observability. So with that, thank you very much.
Thank you, Dave.
Tabs. So thanks, everyone. Raise your hand if you or someone you know has been impacted by layoffs in this past year or so. Right? So a third to half the room. I think this is usually when we come to these search conferences, there's like 1 million people hiring and then like a few people maybe passively looking for jobs. And definitely this has not been a great time for the tech market. Not a fun topic, but something that's really important. I want to mention that a colleague in the community who I don't think is here, David Albrecht, who helped to build this amazing search application for posting jobs. For a long time, I was sort of just spamming the jobs channel in Search Relevance Slack. So I definitely encourage everyone to go into the Search Relevance Slack. You can go to opensourceconnections.com/Slack and check out the jobs channel. I periodically get some LinkedIn alerts, scan them, and post them to nextsearchjobs.com. You can also go to nextsearchjob.com. It's just like a Streamlit app and see sort of like what jobs are out there. But I also want to, more importantly, I want to advocate that if you're hiring, please do keep this job board up to date, post things. If you know of something, maybe a few months ago you posted something, it's not a bad idea to just, mention it again. Please do post that. It really does. People do see it. They use this to look for jobs because I think it's really important for us in the community to really support each other during these, I don't want to say unprecedented times because that's been during these times. So yeah, that's all I wanted to share. That's all I got. So yeah, please do check out the jobs if you're looking, if you're wanting to post something, and keep that job board up to date. So thank you, everyone.
Okay. So Peter Dixon-Moses.
Okay, so this is a our audience participation one. So in a moment, hopefully, we'll get a QR code. There we go. All right. So participate at your peril. No, actually, it's really easy. And I'm going to try to keep this as short as Doug's. No, somewhere in between Doug's and Connor's. So that's a big range. Yeah, I know. Set my timer. Okay, so the goal for this talk is to leverage our collective hindsight to brainstorm a list of core search metrics, ideally that are actionable for search teams and owners that we all know have saved our collective bacon in the past. So does everybody, is everybody able to get this QR code? Cool. All right, so, sorry, I just moved it out of the way. Does anybody still need it? It's bit.ly/flying_blind, and I'm not sure if that's still something I can say, but I liked the aircraft analogy. So this is the impactful search metrics tab, and these are what we think about as our standard core metrics. So please feel free to fill in core metrics here that have really helped you mitigate search issues, right? They really make an impact on search. And I'm going to put in a couple just to get started that may not be standard here. Just so bottom of the top, and there's probably different names of this, just to get people going, is a set of queries that I like to just keep an eye on for just to understand where there's a chance to improve things. And these are a lower percentile of the most popular queries that you see on your site. Sorry, a high percentile of the most popular queries, but it's the lower end of that distribution. So it's going to be different based on how many queries you are actually looking at. But say like the bottom, so say like the top 10% of your queries by traffic that perform in the bottom decile by click-through, relevance, whatever your relevance metrics is. Another metric I like, and I see people are putting stuff in, which is great. Another metric I like to keep an eye on or try to find a way to track is emergent search terms. So what are people searching for this week that they weren't searching for last week? And I'll let people fill a couple things out. Okay, we got some good stuff. You can keep filling that out. I'm going to move on to the embarrassing tab. So the embarrassing metrics don't necessarily move the business, but these are the searches that your boss immediately slacks you with a screenshot of. They hopefully aren't that common, but they often pose an outsized risk to the business. So they may not move metrics, but there's something that you want to know about, ideally proactively. And I can put a couple in just for fun. One here is that product color intent matches model skin tone. That's a good. That's one to watch out for. And also, there we go. We got some good stuff coming in here. I also just any kind of not safe for work content that leaks through for safe for work queries. I've got some real fun stories with that one. Cool. So I think you can keep filling those in. What I'm going to do, and OpenAI kicked me out today, so I was going to just summarize it here, but I'm out of time, and so I'm going to do it offline the hard way. But I'm going to take these metrics and I'm going to put them together and post them back. This is my info here. If you're interested in continuing the conversation with me, I'm going to post this back to Relevance Slack so you can continue the conversation there as well. But hopefully we can get a nice solid set of metrics that everybody likes out of this. And that's my talk.
Thank you, Peter. Right, next up is we're going to have Gus. You'd like to come down?
Cool. All right. My name's Gus. I'm here to talk about JesterJ. I'm also, you might also know me as a committer and PMC member on Lucene and Solar, and I have a business called Needham Software LLC. But JesterJ is what I'm going to talk about today, and JesterJ does document ingestion for search, which is basically getting your documents into your search engine. It's built to be search-oriented, so it natively handles multi-value fields. It can send to Solar in batches. You can use it to transform your documents, enrich your documents. It has support for pre-analyzing your fields in case you want to offload some information, some of the work on the text analysis into your infrastructure that's doing the ingestion, so you burden Solar a little less. Sometimes that allows you to use much bigger machines in the ingestion, then shut them down, and you don't need to keep paying for them. You can pull documents off of a file system. You can do it off a JDBC source, so that is hopefully going to be an alternative to data import handler that can actually be used moving forward. And Tika text extraction is also available as a processor. So if you started out playing with Solar Cell, this is a road forward on that. It has a bunch of other things. You can change fields. You can template fields. You can fetch URLs and add that information to your document. It's made to be easy to extend, so you can write custom processors. It's also made to be easy to use and start. It hopefully has a fairly low barrier to entry. You basically write one simple Java class that's very stereotyped, and that defines your plan for what you want to do in your ingestion. You pack that into a jar, and you basically give it three things: Java, what I give you, what you made, a name, and a password. And that password will be the password to the embedded Cassandra database that it uses to track fault tolerance. So you can even go query that directly. Since it's a Java, since I'm doing Java here, and it's compiled already, anything that produces JVM stuff potentially could be used to write your plan. So in the future, I'd like to investigate using a variety of possible languages in case Java isn't your favorite. How can that be? So it's also meant to be fairly safe in that it does fault tolerance automatically. It remembers what you've scanned, so if you shut it down, start it up again, it doesn't send all the same documents over again. And if it dies in the middle, the first thing it sends when it starts back up is whatever was already in flight. So it knows all that stuff, and it keeps track of that with the embedded internal Cassandra. It's almost only once delivery, but technically it's at most once delivery. Of course, with the two generals problem, that last bit where you go down while you're sending something to Solar, you never find out that you didn't succeed. That one, of course, I can't handle. Future versions will also allow you to tweak it so you can instead do at least once delivery, but right now it does at most once delivery. It should be flexible. You can build linear pipelines if that's what you want to do. You can have a pipeline that feeds multiple destinations. You can have multiple sources reusing the same pipeline. And in fact, you can have decision points and direct some documents one way and some documents the other, and it supports a full DAG, directed acyclic graph. And that even includes disconnected. So they don't even have to be connected parts of a DAG, like any DAG. And here's some pictures of DAGs that I built. Some of these are unit tests here, actually. These are in my unit tests. This is one I discovered a limitation and performance issue that I need to solve. Turns out that putting a whole bunch of outputs actually slows you down because it has to do a lot of writing to Cassandra that way to keep track of what should have gone where. So Cassandra is, currently I think it's my performance limitation. I'll be working on that. I just recently released 1.0 of this, so it's ready to use. It should be useful for people. I also want to point out that in the latest versions, this one's from more recent code, I actually have the ability to show you how many documents are in flight. So you can actually start to get an idea of if you have a slow step in the middle or something like that. I guess that's most of what I have to say today. If you have any questions, feel free to ping me. Certainly try it out. You can find it. I didn't put the URL up here. Okay, well, if you search for JesterJ on GitHub, you should certainly find it there. Also, if you use www.jesterj.org, that will quickly take you to will quickly bounce you off of a page that's way out of date to the GitHub. So that's it.
Thank you, Gus. Now, we're going to try again with Michael.
Yay. So now the only issue is I have to find my window. There. Yeah, it was full screen. There. Okay. Cool. So, I want to show off a new thing that we're putting in OpenSearch. It's still a work in progress. This is literally running on my laptop, though the code's all up on GitHub. But yeah, so this is not actually merged into mainline yet. Well, some of it is, some of it isn't. But yeah, I just wanted to kind of show this thing off because I think it's kind of cool. So let's start I'm going to index a few documents, for an order history index. This is near and dear to my heart because I used to do order history search for a large e-commerce site. And yeah, when I search, one of the things you see is with these products, like, oh, here's a pets product, poop bags. Here's a t-shirt, and we have an adult product. Use your imagination for what it is. I'm not gonna go there. But yeah, so this is potentially embarrassing. That, yeah, maybe we don't want to show adult products by default. So, theoretically what I could do is go and like modify all of my queries and say like, oh yes, let's add a must not clause for adult products. But alternatively, you can use search pipelines. So these are modeled after ingest pipelines. So yeah, little pluggable processors. So in this case, I'm going to create a pipeline called exclude adult that injects a filter query that says must not be category adult. So I created the search pipeline, it's acknowledged, and now I can run the search referencing the search pipeline, and sure enough, no adult products, only 2 hits. Yay. Now, here I've added it in a URL parameter. Maybe I don't want to do that. Maybe I don't want to go and change all the spots in my code where I'm sending these search URLs. So what I can do is I can say for this index, by default, we're going to exclude adult products, and then, hooray, it still works. So I'm going to skip over ingest pipelines because I'm sure you all know ingest pipelines. So let's go down here. What if we want to do something more fancy, right? What if along the way we decide, you know what, we're going to rename the product title field to title. Product title's too verbose. And yeah, I just want to modify the results as they come out. So I'm going to drop in a response processor. I'm going to update my pipeline. Oh, and I've added in this append query. Because yeah, one of the things that I've never particularly liked about OpenSearch and Elasticsearch is that I've always found it really hard to get the query that was actually sent. Unlike in Solar. Solar makes that so much easier. But what you gonna do? So now when I do my search, first off, we can actually see the transform. We can actually see the transformed query. That's why I never work full screen. So here's the transformed query, and sure enough, product title's been renamed to title. Hooray! So for my grand finale, I'm going to do an inline pipeline. So here I'm actually specifying the pipeline as part of my search request. I'm going to search for dog poop bags. I've got a complicated script here that's going to modify the query, as it goes through. I'm still going to exclude adult products. I'm going to exclude some offensive words. And yeah, I'm still going to rename the product title and append query. So, one pipeline. What, 5 processors? Let's do it. So, sure enough, we've got our Earth-rated dog redacted bags. Product title's been renamed to title. We have the query. And what this script did was it took dog poop bags and turned it into dog and poop or poop and bags. So yeah, so that's it. That's search pipelines. And we are very eager for people to, start contributing processors. You too can create these nice little pluggable things. We're excited to, we've been talking about ideas like external re-rankers. I'm talking with Roman about wanting to integrate with MetaRank. I think that would be really cool. Maybe like quirky on the request processing side, and eventually, I'd like to turn these, beyond being just linear to being full DAGs. Everyone loves DAGs, so yeah. Thank you.
Awesome. Well, that was worth waiting for, wasn't it? Okay, so our next lightning talk is Aruna. Aruna, where are you? The next.
Hey. Okay, so today we saw so much about machine learning, NLP, vector search, and all that. So I thought, okay, before we go today evening and roll up our sleeve, there are a few things that I always evangelized about capturing user signals, and that's what I wanted to talk about today. I'm Aruna Govindaraju. I'm part of the Amazon team who's here today, and I'm an OpenSearch specialist architect. I have a lot of experience working with retailers the past 15 to 18 years. So with that, this is going to be super quick as compared to some of the cool presentations you saw earlier. So 3 things I always thought would make a big difference when it comes to any kind of search, when it comes to capturing user signals, be it any kind of a search, and that's the top 3 things. One is the query. Pretty much in most scenarios, we capture the user queries, but we don't really go in and analyze as to what to do with those. So some of the things that I've evangelized and some of the things that worked for some of the retailers that I worked with is try to identify what these queries are all about. So categorize them into brand, category, and keyword. So, and you exactly would know at that point in time what to do with those. So if it's brand, just take them to the brand landing page, or do a brand listing page, or show the top products that is related to a brand. Similarly with the category, so if there is a specific category and there is multiple categories and there are similar categories, then you would want to identify what are the top products you want to show, or address or route the users to the correct category page. And third is the keyword. We see all kinds of keyword, long tail, short forms, and all kinds of keywords. Now, one of the key things that I always recommend that you look at is, are these keywords from a single field, or those title field, or there is a cross-field search which is happening. And accordingly, you will know what exactly to do with those. If there is cross-field, you know which fields to boost, how to boost a cross-field search and all that. So these are the 3 things. So search versus land, where you basically, depending upon the kind of keywords, you decide whether it should be a simple search, a full text search, or it's going to be a landing page with a keyword redirect. And of course, the top products for category-based search and a single versus cross fields. The second thing, the most important thing that I always recommend is the faceted clicks. Most often, people miss out on the facets, and they are like overly in love with facets because we love recall. So we want to bring all the products you have in your index onto the front end and then expose as many facets as possible on the left-hand side. Often missing the fact that, are you even capturing what the users are clicking? What is the order in which the users are clicking through them? Are the facets being clicked? So you are capturing signals because a user is clicking on it. But what are the things on the facets or on the results page that users are not even clicking on? So those are like negative signals which needs to be captured. So if I have, like, say, top 5 facets on my page all the time, and there is always 1, 3, 4 is being clicked, that's a beautiful signal that 2 and 5 is never used. So why even have it on the second position of your facets? So try to look at both the positive and the negative sides to the click streams and identify the order in which your facets needs to happen on your search results page. And the third thing is the search results. So that's the glorifying search results, right? We put everything on the search results as possible. We have the promotions, we have the targeted products, we have the advertisements, and then we have the synonyms, and we have the auto suggestions. And then we have the whole bunch of results, which is like farther down the page that most of the time users fail to even look at. And imagine some of the retailers have 90,000 products, and you really want to show only top 10. So some of the negative signals here is, the signals that we would like to capture, let's go with the positive side, is what are the top things that on your results page that is being clicked? So is it like auto suggestions? Are they trying to just find terms on your suggestions list? Are there clicks happening on your, say, synonyms? So you have enable synonyms in your page. So they're not even in your results yet. Your user is still interacting with all the other search features that you have created. And then the other thing is click metrics. So you have, again, the same thing that we did with facets, right? What are the things which is clicked and what are the results which are not even clicked? So you've got the top 10 results and you've got clicks on your first and your second result, and then the user skips to go to the fourth and the fifth. So do we identify that the third result has never been used? So is it relevant? Do we need to even have that on the top? These are all the signals that are important for us to build the search system using, like, say, ML models. So tomorrow, if you want to use like learning to rank or bringing the semantic conceptual search into play, we want to see how to even improve the search results. But when we don't know what the users are searching for, then there's no point in even trying to build a targeted search system. And of course, some of the other signals that can help you build useful search features on your search results page is zero results. Now, we are looking at, okay, zero results, so we don't have that content. So why not recommend and suggest? And when you recommend and suggest, how many clicks goes to your recommended results? So that shows an interest. That helps you build the required features on your results page. And the number of searches per session and the linger time, right? How many times a user is expanding their query to actually do multiple search? Now, why do we want the search users to get frustrated with multiple rounds of query to find that one beautiful document? We would rather do that for them, so that's when query expansion would come into play. So we would build features based upon user signals. So identify these signals as input to improving your search system. And of course, the time, the linger time, the time that the user spends on your search results page, the drop rate, how fast they get out of the search. That clearly shows that they don't want, either they found the result and they clicked on it, they're out of the site, or they never found anything interesting that they exited the site. And these are some of the things which helps you analyze whether one, either improve the search, build relevancy modules, build queries which has relevancy modules implemented with it, or use LTRs to bump up your results to the top, the relevant results to the top, versus, so that's the option one, versus build search features like auto suggestions, synonyms, spell checking, personalized results, enable preference, or find something which is trending right now and boost your results based upon current trends. So again, thank you. That was what I wanted to say. Thank you. Hope you enjoyed it.
Thank you very much, Aruna. Now, next we have Uri.
So this presentation is not meant to be 5 minutes, so I'll try to speed up the things that you probably all know and some of you can teach me. So let's start. The gist is how to make the search results explainable. Okay. So a few words about me. I run a machine learning consultancy that does only personalized search and recommendations. It's the same thing, right? So personalized search is recommendation. Recommendation is personalized search these days. The UI might be different, but the underlying vector search is the same. I also host Explainable, a podcast on machine learning in Israel that is pretty popular. And I'm one of the organizers of PyData. And I've been using Vespa AI before it was cool, back at the days at Yahoo. So if you want to complain about it, then I hear you. Cool. So we do a lot of search at Argmax. Most of our clients are in the edtech industry. We also have quite a few e-commerce, and there's more than I would expect in the creator economy, like recommended videos. And again, the architecture is the same, right? We have encoders for image, for video, for text. It's pretty convenient. Okay, so why should we care about explanation? So if you work in any domain that you're accountable for what you do, like finance, legal, then sometimes you have to explain why you recommended that certain things. But on the other hand, it's also beneficial if you don't have to explain. Research shows that if you tell people why you recommended that items, they tend to buy more. They tend to think it's personalized, right? You're seeing this item because your friends bought that item. Okay. So recommendation systems are essentially vector searches. This is how recommendation systems looks. We have plenty of items. We know a lot of things about the users, but we have limited space, and we need to make an informed decision. What items do we show to the user? There's some sort of preference matrix that looks something like that, but truly, we are trying to reason about the statistics, like CTR or conversion rate or any other statistics. And the approach is to vectorize things, right? We have item vectors, and we have user vectors. Now, I'm not going to talk about how to create these vectors. That's kind of your problem. But once you created these problems, you can index them and run a vector search. Now, this is your goal, right? You want the multiplication of the vectors to be the conversion rate or CTR or whatever your goal is. So this should be your objective when you train your model. And keep in mind that you can implement both item-to-item recommendation or user-to-item recommendations. It really depends on the model and your business objective. But from our perspective, the same architecture. Cool. So there are plenty of ways to vectorize items and users. One of the coolest one is Clip, when you have an encoder for text and encoder for image. And in real life, an item has both an image and text and sometimes audio. It really depends on what you're doing. Like there's an entire zoo of encoders on Hugging Face and LLMs and what have you. But those are not really explainable. Like if my entire vector is the clip embedding, then how can I explain why did I recommend anything? So what we do, this is a very neat trick that you can go home and implement tomorrow. Very, very simple. We represent an item as a concatenation of different encoders. We can have an encoder for a category, encoder for clip, for image, for text, whatever. And this is how we present an item. Now, how does that help us with explainability? In real life, it's not going to be a one hot, neat encoding like that. It's going to be something messy like that. But the same logic applies. Cool. And then we have this giant box, a vector search. Now, no offense, Pinecone, Weaviate, I don't really care. We have a vector search. The API is the same. We give it a vector, and we get the k nearest neighbors. Same goes for user to item, right? From an application perspective, you choose one vector search, and you stick to it. Now let's talk about a few notations. So we talked a bit about encoders, right? For example, the clip encoder, encode image, encode text. And there are plenty of encoders, more than I can name here in 5 minutes. And let's talk about a bit about filters. Filters in vector search are, you can think about it as like replicating the vector search. There are also more fancy ways to go about it, implemented in Weaviate, Pinecone, Vespa, what have you. But those are fields that you don't encode into the vector. Now let's see how encoders can be used to explain things. So let's assume that I have these products on my supermarket, and each item has a lot of properties, right? It has a price range, it has diet preferences. Is this item for people who do keto like me? Is it like for people who are vegetarian? And all of these features can be encoded separately. Now, when I recommend an item, I can try and reason about what amount of these features, which features will actually correlates to the user preference, right? So if I recommend, for example, these vegan cookies, and I know that all of the user history, all of the items previously purchased are vegan, then I can name that this was the reason. And this actually, it's very crucial for conversion, like to make the user feel that the recommendation is personalized. So the idea is like this. Once I concatenated all of the features, then I can calculate the distance. The vector search usually outputs the overall distance, and I can try to break it down and to see what is the distance per each component. Right, so this is very cool. I can look at the component-wise breakdown and choose the feature that was closest to the user vector. Now, the features are not equally important, right? I can, for example, it might be that diet preferences are more important on a general population than price sensitivity. And these weights can be learned with a model. Now keep in mind that we learn only like 3 parameters here, and in the general case it could be 100 parameters. It's still a relatively small number. We can learn it with least squares. We don't really need a fancy GPU or any kind of specific hardware. You can do it on your laptop in seconds. Cool. So now we know the breakdown of the distance, and we have an explainable recommendation systems. Just as easy as that. That was essentially the gist. If this is like the math behind learning the weights. And let's jump to the summary. So we want an explainable recommender system. We can use pre-trained models, and we have a lot of pre-trained models these days. And we can gain also from explainability regarding if you're obliged or by the legislator to be explainable, or just you're trying to boost your sales. And the trick is to use compositional encoding, multiple encoders, and concatenate them together, multiplied by a certain weight. That's it. Thank you.
Brian, you're next up.
Hi, Haystack. How's everybody doing? End of the day, we gotta wake it up. But I hope you're all still comfortable, doing well in your oversized plush chairs. I want to thank OSC for a great conference and for ruining regular conference chairs for us forever. I was hoping for a bigger screen, but we'll make this work. All right. So our talk today is measuring performance search for vector search. We've heard a lot of great vector search talks today. We're going to talk a little bit more about performance, the other side of relevancy. So I'm from KMW, Brian Nauheimer, Kyle Marcotte, search consultancy, been around for about 12 years out of the Boston area. We do a lot of things, but the one that we want to talk specifically about today is the last one, search performance tuning. So audience participation time. Who here is running a search cluster in production? Show of hands. Just about everybody. And who is running one on a major cloud provider? Just about everybody. And out of all of you, who in the last 6 months have been asked to decrease your footprint and your cloud bill? Yeah, us too. Okay, so that matters. Search performance matters, right? And it matters in the context of dollars. Why did this happen? We've got some ideas. There's some things out there that's happening that's affecting us all. But I think the point of that is that excellent search relevancy needs to be economically viable, right? What we can't control is the level of usage of these search products. We can't control the data set, how much data we have. We can't control what the customer is going to be expecting us to be able to do. But what we have to work on is, what are my performance metrics look like, and what's the solution cost? And those are tough problems. So we like to look at key performance metrics, specifically query latency, index creation time, update latency, query latency during updates. The last one, if you're coming from the Lucene-based world, that's a really important one. That's when your system is under the most stress, when we're feeding more content into it. So this is the stuff that we look for. And of course, in the context of both relevancy and cost. So high-level best practices for those building search products or building like the engines in the room. I'm sure you're already doing this, for the enterprise solutions, and a lot of the people that we talk to, they're not doing this all the time. So just some best practices: create automated tests for all the key performance metrics, run these tests at a variety of throughputs. Performance only makes sense in the context of throughput from the search side. Run these tests regularly and understand them in the context of the new features that you're creating, because we can create wonderful new ways to do relevancy, but if all of a sudden we've added lots of latency time, or we've added now tons of cost, I saw a couple presentations today with the triangle, and it's like these things are in balance, but it's really easy to make a solution way more expensive and not improve your relevancy. Like that can happen. So we got to be measuring these things with each step to make sure that we're getting what we need. And then performance testing in the new era. So what I've talked about so far applies to vector search, but it also applies to lexical search, right? So these are things that we should be doing. Why is it important to do this in the new modality that we're living in? Well, for vector search, these technologies are relatively new, and that's the example we're going to give in a second. Kyle's going to walk through. We actually had a customer project, and they asked us to evaluate, do performance evaluation on Elasticsearch. And we learned a bunch of things that we weren't expecting to learn. So we're going to talk a little bit about that. And when you look at hybrid search, I mean, really you're taking lexical search and you're taking vector search. So not only are you, have the issues of the two independently, I bet if I ask 10 people in this room, how have you implemented your hybrid solution, I'm going to get 10 different answers, right? There's some complexity to this right now. You're querying different areas, maybe you're doing some re-ranking, you're definitely getting some encodings. There's a lot going on. And so if any one of those steps is giving you trouble, then you might be in trouble. So it's just important that when we're talking about hybrid search that we're making sure we're testing that all through. So I'm going to turn over to Kyle. He's just going to walk through quickly the force merge problem.
Yep. So hi everyone. We've had a lot of great talks, and some from people that have vector databases and stuff. But vector search is available in Lucene now and in Lucene-based search engines. And like Brian was saying, we were asked to help a customer evaluate how much it would cost for them to use this new feature in an Elasticsearch cluster that they already had, and wanted to walk through the benchmarking exercise that we did for that, and kind of the things that we learned and experienced there. This is kind of just a summary of what we learned, and the big thing is that the index size, at least from our experience and the exercise that we did, was the primary thing that was driving the cost, and that's mainly because the vectors and the dimensionality of the vectors drove the amount of RAM that was needed to fit the index in memory for supporting low latency queries at high throughputs. And the best performance, we had specific latency and throughput requirements, and the only way to achieve them in the best performance only happened after we merged the index down to a single segment. So merging the index was required to have a successful test. This is the data set and model that we used, and just a graph showing the size of the index that was part of this test. This was a 10 million vector index, and we tested it with approximate KNN queries. And we had specific latency target of 100 millisecond queries, P95 100 millisecond queries at a throughput of 10 queries per second. And when we built this index and did the test initially, we couldn't achieve that throughput with the target latency. And then only after we force merged the index down to a single segment and ran it again, we not only achieved the target, but we actually were able to support much higher throughputs. Yeah, so the optimized index supported those throughputs, and was kind of consistent with the idea that throughput wasn't really driving the cost, but just the size of the index. And one kind of thing that was surprising to us was actually force merging the index with a dense vector field. Took a lot longer than I guess normally it does with like just a lexical index. And that was surprising for us. It also has some implications in terms of operational complexity and managing this feature in a production system. So that's kind of the takeaway that we're wrestling with is we had specific performance that we know that we needed for this particular
search application, and we could only achieve that performance on a merged index. Merging the index took a long time, so there's things to consider in terms of what does the deployment model look like, how do you manage when the data goes live, and what are the expectations around update latency and SLAs. So yeah, we just wanted to share the experience that we've had looking at this feature, and look forward to hopefully talking with other people that have been working with this and finding out what your experience is like too.
Thank you, Brian and Kyle. Right. So this is going to the next one is going to the last of our lightning talks, and then we can all take a quick break and then go off for dinner. But I'm now happy to welcome to the stage someone you may have heard of, Mr. Eric Pugh of Open Source Connections.
Hello. All right. Is this going to work? All right. Awesome. So I get to go last, so I'm between you and cocktails. Let's get the screen up here. Yay. All right. So my lightning talk is please help. Whoa. Please help Atita rate some documents. So raise your hands if you know what human judgments are. Awesome. Okay. So not going to explain it, just going to assume it. If you don't, ask me later. This is interesting. Do we want to try a different adapter? So please jump on relevant Slack and go to the Haystack channel and put your email address in if you want to rate some documents. And my colleague David is going to frantically add you to Cupid if you're not already a member. And if you are, do we want to use yours? We can log in. So yeah, so go ahead and put your email address in, and then David will add you to a Cupid case. And then we're going to rate some IceCat queries. So we have, go ahead and log in, Charlie, and Cupid. Yep, and you're in. So Charlie's going to log in right here. Go ahead, log in, and Charlie at Flax. There we go.
Yes, I'm still got the email address from the company I left like 5 years ago.
All right, terrific. Okay, so Haystack rating party, right? So yeah, so in Cupid, we have a team. Let's see if this all works. Haystack. There we go. There's only 6 of us in here, so I'm hoping we get some more people in. Okay, terrific. David, you've joined. Jeff, who I think is online, has joined. So we can jump in here, and we have a case here called the Haystack Rating Party that has 135 queries. Now, for those of you who came to the meetup last night, you might have seen some of the queries in the vector demo that Renee gave, right? So this case is a mix of queries and documents from an untuned search engine as well as tuned using the vector stuff. So I'm going to go ahead and bring up our rating interface. Let's see if we get this. All right. More judgments are needed. And let's see, can I paste Control-C? Is that going to work? Here. And right. There we go. Oop, that's not it. All right. David, if you can, I'll have you paste in. So here's the new rating interface that just got rolled out. It's sort of the classic card interface. If any of you are familiar with Discernitron, which was the Wikimedia evaluation tool, it's very much inspired by it. And I've got a query here for a stylus. Now, and here is a document. Well, it is an Epson replacement blade for a Stylus Pro automatic paper cutter, but I don't think this is what the user was looking for. If I'm curious, Hey, there's some scoring guidelines, right? Max Irwin might find these familiar. He wrote the original ones. And so I can go here, I can skip this document, I can say I have no idea what's going on, or I can say these are terrible search results. All right, PS4. Is this a PS4? No. All right, we have some terrible search results. Here we got books. Books cover, this query is kind of a difficult one. What am I going to return for books? So I'm going to skip this one, or say I can't even rate this one. Surround sound speakers, I mean, it is a docking speaker. It looks like, I don't know. I'm going to go with fair. And a gaming laptop. No, this is not a gaming laptop. So here we got a bunch of queries. And over time, I'll just kind of go in here. So these are all my query document pairs. For those of you who maybe used Cupid in the past, you maybe struggled with the fact that all the query doc pairs in the UI required a live search engine, and you were kind of interacting with it. And as the search engine index changed, so did what you were rating. This now, we kind of snapshot that data, store it in here. We can modify it over time. So these are all the query doc pairs. And here are my judgments. So, and hey, look. Oh, Jeff, you've been awesome. Look at all those. Oh, wow. Jeff has been very busy. He's rated a bunch of documents. Jeff's organization has the largest Cupid case that has been regularly maintained. It's almost 1,000 queries and takes about 20 minutes to load inside of Cupid. So he's used to lots of ratings. All right, so we got David. Thank you. Thank you, Froh. So we got a couple of ratings in here. So the way Cupid is set up is we're asking for up to 3 ratings. Okay, so it'll keep prompting for more ratings until it gets 3. And then when we import them back into Cupid, into our case, and let me go ahead and give it a stab and see if that works. It's basically going to just average all 3. And so fairly naive, but it works. So let me bring up this Frog Pond report. So right now we have no ratings. So I'm going to refresh the ratings from the Haystack Ice Cat rating party. Cross my fingers that everything runs. And it did. And hey, look at that. We've got ratings, okay? Now, as you can see, we still have lots of frogs. The frogs mean that we have unrated documents, so we've only done a few of them. But if I bring up the Frog Pond report again, you can see that we have 3 queries that are fully rated, 2 queries that are missing one. So we got a couple that are mostly rated. We still have lots of ratings to gather to help Atita measure whether vector search or non-vector search, how well does it work. So yeah, thank you very much.
Thank you, Eric, and thank you everybody for bearing with us with all the replugging adapter fun we've had. I must admit, every single event I've ever been to in my entire technical life has involved some messing about projectors or screens or Wi-Fi. It never goes smoothly. So that's day 1 of Haystack. Can we have a round of applause for all our presenters today?